Right, so on deck this time, maybe you would be so kind as to read it to me.
A steel ball bearing a small sphere is released from rest at the surface of a very tall column of oil.
Oh, this one. Okay. Yeah.
And its subsequent motion is recorded and analyzed. Describe the motion of the ball bearing you would expect to see and explain this motion in terms of the forces acting at different times on the ball bearing.
Okay. So, what do we expect to see? Well, we expect, I suppose we could think of it as a graph, time, velocity. At the beginning, it's at rest. Then it will move faster and faster. But then it will reach a constant speed, yeah. And this is called the terminal velocity. So there's two forces acting here, the weight and the drag. And what will happen is later the weight and the drag will be equal. So how can we put this? We can say at first there is no drag force and the ball accelerates down. Soon, though, no, what do I want? After a small time, the drag force will increase until the drag equals the weight. At this point, the ball is moving down at a constant velocity known as the terminal velocity. Man, oh man. Did anybody write as much as that? That would be nice if you did. No? What did you write, Siba?
The ball will accelerate, then will move in constant speed.
Let's check the marking scheme to see if you would have gotten your full marks for that. I might have overkilled this. You seem to think I did overkill it. What's the verdict, Siba? Do I get my 4 marks?
Yeah.
What's it say?
Me, no.
Yeah, but what's the marking scheme say?
Initially accelerates at G.
Yeah.
Because weight down and no little upward force.
Yeah.
Accelerates less. Because drag or fluid friction means resultant force less. Eventually constant speed. Because drag force balances weight.
Yeah, I don't know if I got full marks because there's one thing I left out, which I was considering writing, and I didn't write it because I thought I'd be over the top to write it, but I guess not. I was going to say at first there's no drag and the ball accelerates down, and I was going to put here at G, but I thought no, that's just over the top. But I guess not, because he has that in his marking scheme. Does it say at which point you get each mark, or is it just 4 marks and doesn't say?
There's like 1, 2, 3, 4, 5, 6 points.
Ah, so if you had 4 of the 6 points, you'd get the full marks. Alright, so I'm okay then. So there was probably 1 point for saying at first there's no drag force. That was 1 point. I think the ball accelerates down at G. That was another point. After a small time, the drag force will increase. That was another point. And then drag equals weight. That was another point. And then moving at a constant velocity was another point. And did he mention terminal velocity? No, okay.
So drag equals.
Just drag equals weight then. Alright, fair enough, fair enough. Next, now, how many marks for the next one?